Okay, yesterday we started working, our last 2 days we worked with division of polynomials and synthetic division, synthetic substitution. Questions you have on any of the problems that we've dealt with? Once again, it's numerically it's not very challenging, but it's just a new technique of being able to get through things. Any questions at all? Think of the degrees as sort of place values, if you want to think of it that way. Tens, hundreds, thousands, 10,000s. Think of it that way, as the place values go. The degrees of the polynomial is like a place value also. So if you don't have a term there, you have to put a 0 in there to hold the place value. Think of it that way a little bit. Questions, anything? Okay, we're going to build on that today. And some of the things that we're doing today will be very similar to what we just did yesterday. Today we're going to work on what's called the rational root theorem. But basically it's what we've been doing the last couple days. We're going to use a lot of synthetic division. Are those factors? Answer the questions. Here's your calculator. Are those factors? Is 9 a factor of 57, 56, 78? Is 9 a factor of 64, 53? Is 3 a factor of 68, 34? Is 13 a factor of 56,943? Do we have factors there? Make you just read down, yes or no?
No. Yes. Yes. No.
And the question I go back to is, how do you know when you don't have a factor or when it is a factor? What we talked about the other day. How do we know when it's a factor or not a factor, Angelique? When the remainder is 0. When the remainder is equal to 0, or you have no decimal, which is going to get a fraction. Okay? The common thing, well, when it goes into it evenly, well, sometimes it could be an odd number, so it may not go in evenly. It could go in oddly, and that's okay. But when you don't have a remainder, which means you have no decimals, you have no fractions there, it's going to be a factor. Well, is x plus 2 a factor of? Is x plus 2 a factor of this? Is x plus 2 a factor of it? Well, let's go back to what we did yesterday. Let's put our value out front. What goes in the little box? Maybe what are we going to put in our little box? 2? Negative 2? Which one? All right, that's fine. I'm just checking. Carissa, is it a factor?
No,
Why not?
there's a remainder of 27.
A remainder of what?
27.
27? The remainder goes there. So we drop down, we have 1, -2, 3, -6, 10, -10, 20, add down, we get 27. So we have a remainder of 27. So it's not going to be a factor. Why? Because of our remainder theorem, for it to be a factor, a remainder has to be a value of 0. Well, what if I want to evaluate this polynomial at -2? What would be the value of this polynomial at -2? What's the value of the polynomial at -2? Well, it's better today. I only see 5 heads going down today to sit there and work it through the calculator. What's the value at -2? Kirsten, what's our value? 27. By synthetic substitution, if I put -2 in there, my value at the very end is a value that's the value of the polynomial. Okay, like I said, much better today. Yesterday I had only maybe everybody's head go down except for 1 or 2 of you. Today now, I only had about half of you go put your heads down and start grinding it through the calculator again. Okay, that's better. Oh, I don't want that. You really don't want to see my emails. And we talked about this also yesterday, so we're going to go to the back side here. Because the most important thing, the key idea for what we had today is what is called the rational root theorem. Okay, given a polynomial p of x. Okay, what we're going to look for is we're going to look to see what all those other factors are. We did problems that you had in your homework today. We did problems yesterday where, is this a factor of it? Yes, it is. Then what's the other factor or factors? And then you were able to factor it down even further. Okay? But what's going to happen now is, I'm not going to give you, is this a factor of this? You're going to have to generate, is this a factor of? Or is this a root of a solution? So you'll have to generate possible solutions to an equation. And we can utilize the idea of a rational root solution, or rational root theorem, given any polynomial p of x, the possible rational roots. Now when you're talking about roots, it means the solutions of a polynomial. It means the zeros of the polynomial. That's what makes the polynomial equal to 0. I'm trying to figure out what makes our polynomial equal to 0. So when you talk about roots, these are called x-intercepts. These are called zeros of the function. We've named them many things at this point. We can now call them roots of the polynomial. It's what makes the polynomial equal to 0. And if we take a look at the polynomial, we can come up with possible values. Will they work? Some of them will, some of them won't. But we can at least get possible values down there. When I'm talking about possible solutions, this is going to be the first thing that we're going to list. And then we're going to trial and error it. We have plus minus, the factors of the constant, divided by divided by the factors of the leading coefficient. The factors of the constant divided by the factors of the leading coefficient. and we're going to use synthetic division. And the connections to what we just did with synthetic division and synthetic substitution, we are trying to figure out what makes my value of my polynomial equal to 0. On the front side, I asked you the question, what's the value of this polynomial? If I would sub -2 into this function, I'm going to get 27. What we're looking for is what makes p of x equal to 0. Well, where would that occur is right there at the remainder. If I would substitute -2 in, it's not going to make my polynomial equal to 0. And to be quite honest, the only values that would work for this, I knew this wasn't going to work right from the beginning, because if I take a look at my constant, my factors of the constant are 1 and 7. My factors of the leading coefficient are just 1. So possible solutions would have been plus minus 1 over 1 and plus minus 7 over 1. Those are the only possible solutions that we would have with this, which is nice because we have just plus minus 1 and plus minus 7. The only possible values that I could substitute into that polynomial to make it equal to 0 would be those, rationally wise. Now, you might have irrational numbers, that's fine, but we're talking about rational numbers. Rational numbers are plus minus fractions, plus minus repeating or terminating decimals. Those are rational roots. Those are rational numbers. The only rational ones that would work would be plus minus 1 and plus minus 7. No other. 3 wouldn't work, 4 wouldn't work, 5 wouldn't work, 7 wouldn't, or 8 wouldn't work, 1/2 wouldn't work, 1/3 wouldn't work. None of those would work. The only ones that would possibly work are 1 and 7 plus or minus. That's what the rational root theorem tells us. Down here, possible roots are possible solutions. My factors of 8 are 1, 2, 4, and 8. My leading coefficient, I just have a value of 1. So our possible solutions would be plus minus 1 divided by 1, plus minus 2 divided by 1, plus minus 4 divided by 1, and plus minus 8 divided by 1. Or plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Those are the only ones. These are the only ones that would sub in there and get us a value of 0 with our polynomial. And once again, roots, we talk about these roots, it's what makes p of x equal to 0. Those are the only ones. 1/2 wouldn't work. 6 wouldn't work. 1/8 wouldn't work. Some other characteristics. The number of positive solutions equals the number of sign changes of consecutive terms. So the number of sign changes of consecutive terms will tell us the number of positive solutions that you will have. Or the number of sign changes minus 2, minus 4, minus 6. And so on. Or sign changes you have. Most of the time you probably won't have 6 sign changes because your polynomial won't be that big. So your number of sign changes, positive, or number of positive solutions equals the number of sign changes on consecutive terms of number of sign changes minus 2, minus 4, minus 6. To get the number of negative solutions, we substitute negative x in for x, and then it's the exact same thing. Equals the number of sign changes of consecutive terms, minus 2, minus 4, minus 6. So it's the exact same thing, but we have to substitute negative x in for x. The degree of the polynomial equals the number of solutions. And that could be either real or imaginary. The degree of the polynomial will give us the number of solutions, either real or imaginary. So if we take a look at our polynomial, 2x cubed minus 4x squared plus 7x plus 4. Our total number of solutions. Our total number of solutions. That would be what? What's the degree of the polynomial? 3. So we're going to have 3 solutions. 3 solutions. The number of positive solutions. Well, let's count up our sign changes. I start with positive. Okay? I go to negative. That's one sign change. I go to positive. That's a second sign change. I stay positive, so I've had 2 sign changes. So we have 2 or minus 2, minus 4, minus 6. So I can still subtract 2 from that to get 2 or 0. So I'll either have 2 positive solutions or 0 positive solutions. Number of negative solutions. Now what we need to do is substitute negative x in for x. So we have 2 negative x cubed minus 4 negative x squared plus 7 times negative x plus 4. And once you see what happens here, yeah, you could do this every time, but if I cube a negative or take it to the first power, it's going to keep it negative. But if I square negative x, that's going to still keep it positive x. Okay, so if I square this, negative x squared is going to equal x squared. Because negative times a negative will give us a positive. This is negative x times negative x. So I have negative 1 times negative 1 is positive 1. And then I have x times x is still going to give me x squared. But if I cube that, that's going to switch my sign around to a negative. So what this will give us is negative 2x cubed. This is going to stay negative 4x squared. This is going to give me a negative 7x plus 4. Only the negative, or Only the odd exponents will change signs. The even exponents will stay the same. So if I count out my number of sign changes here, I go from negative to negative to negative to positive. Brooke, how many sign changes? 1. I have 1 sign change. So I have 1 negative solution. If I take a look at the maximum number of solutions, I have 2 or 0 positive, and I have 1 negative. I got 2 positive and 1 negative. So I have a total of 3. What happens when I have this scenario? When I have 1 negative and 0 positives? That means that's going to give us 2 imaginary solutions. This is real numbers that we're talking about. These are real solutions. So when I have 0 and 1, this is going to give us 2 imaginary solutions. 2 of your solutions will be imaginary. But when I have 2 positives and 1 negative, I get my 3 then. What this guarantees is you're going to have a negative solution here with this problem. You're guaranteed 1 negative solution because you don't have 0 as the option. Possible rational solutions. What I typically do is just right above my numbers I'm dealing with, I put my factors. Factors of 4 are 1, 2, and 4. Factors of 2 are 1 and 2. And I need to list my possible solutions. Now from what we did on the front side here, when I divide by 1, I'm just going to get the actual number. So I don't really need to show that division by 1. So I'm going to get plus minus 1 divided by 1, plus minus 2 divided by 1, and plus minus 4 divided by 1. Then I go through and divide by 2. So we have plus minus 1 divided by 2, 2 divided by 2, and 4 divided by 2. But what you'll see here is I got 2 divided by 2 and 4 divided by 2. This takes me back to 1 and 2, which I already have over here. So I really don't need to consider them because I already have them here and here. So for our root here, or for our polynomial, my rational roots are 1, 2, 4, and 1/2. Those are plus minus, those are the only possible solutions. 6 won't work. 3/2 will not work. The only ones that can work, we can eliminate or narrow down to 8 possible solutions there. Let's just go down to the bottom one here, get through an actual problem here. I want to determine roots, which means this is what makes P of x equal to 0. I want to determine the roots. What makes our polynomial equal to 0? Which are the x-intercepts, or the zeros of the polynomial. All the same, synonymous with each other. Your English term of the day. So we have number of solutions, number of positive solutions, number of negative solutions, and possible number of solutions, or possible solutions. Well, once again, if I take a look at the number of solutions, Riley, what do we have? How many solutions? What's the degree of our polynomial? 3. Okay, positive solutions. Let's count up our sign changes. Sign changes, I start with plus, go to minus, stay minus, go back to plus. How many sign changes do we have there, Noah? 2. So we have 2 or what? 2 or 0. And, okay, going with what we just dealt with up top, we could do the negative x in there also. And we'll do that just for giggles. Then we'll if I put negative x in here, we would have a negative for x cubed, so I have a negative 3x cubed. This would stay negative. This would give me a positive 5x, and then a plus 2. So only your negatives would change, and a lot of times what I will do is I'll just say, okay, that's a negative up here, that's going to stay negative here, that's going to turn positive here, that stays positive there, just by looking at the exponents. How many sign changes do we have there, Isaac? 1. So we're down to 1 here. Knowing that the maximum number is going to have to add up to the total number of would help you out too. Because it's easy to do the positive ones here. Okay? It's easy to do this. I just count up. I don't have to worry about this. So if I have 2 possible here, that's my max number for positives. I have a total of 3. That leaves how many left for negative? That leaves us just 1. So you can think of it that way also. Okay, possible rational solutions. Okay, we write our factors for 2. We have 1 and 2, and then 1 and 3 here. Constants divided by leading coefficient. So we have plus minus 1 divided by 1, and plus minus 2 divided by 1. And then we need to take both of these terms and divide by my other one, my other factor, which is 3. So we have plus minus 1/3, plus minus 2/3. A lot of times what I'll do is I'll do it vertically. I'll do all my whole numbers here first, my integers here first, and then I work sideways. Okay, I'm going to divide everything by 3, and then if I have other factors, I'm going to keep on dividing by those other factors. So I sort of write vertically and work sideways with it. You do what works for you. That's just how my brain works. Now, we're trying to determine what makes these factors equal to 0, this polynomial equal to 0. The value of the polynomial, as we have learned, is at that remainder of synthetic substitution. So what we need to do here, and there's no easy way of doing this, we just have to try on error. Let's see what makes 3x cubed minus 4x squared minus 5x plus 2 equal to 0. And there's no easy way of doing this. Now typically what I do, this is what I typically do, is I usually don't start with 1. Reason why is because I can eliminate solutions, possible solutions as I go through. I typically start with 2 or 3 or whatever is my next biggest one. Because we'll be able to eliminate solutions. And we need to run this through synthetic substitution. Drop your 3 down, multiply by 2, add down, multiply by 2, add down, multiply by 2, add down, and what we get is we get a value of 0 there. which tells us x equals 2 is a root. It makes the value of our polynomial equal to 0. Now let's take this root. What would be the factor? If my value of plus 2 there is in the little box. If I was dividing by a binomial, what would be the factor?
X minus 2.
X minus 2. Because when this is a minus 2, we put a plus 2 in here, the connection between them. Okay, so one factor is x minus 2. When you get down to 3 terms, write your other factor down. What would be your other factor? If x minus 2 is the first factor, Jordan, what would be the other factor?
3x squared plus 2x.
Which I could use synthetic substitution again if I wanted to, but when I get down to this, what you should feel is feel a little confident that I can be able to factor that. I got a trinomial term. What would that factor to? Preston, what's the other two factors? 3x plus 1, x minus 1? Yes, no, maybe so? Check our minimal multiplication. We got a plus 1x. We have a minus 3x. We have a minus 3x and a plus 1x that gives us plus 2. Now what do we have to do with the signs? Switch them. So now if I check my minimal multiplication, I get a plus 3x and a minus 1x. That gives me the plus 2x. What we are trying to do is we're trying to figure out what makes this equal to 0, using our multiplication property of 0. Well, we already know the first one. This will give us x equals 2. We already determined that up there. This gives me x is equal to 1/3. This gives me x is equal to negative 1. I forgot to print off the homework. That's nice. doing your homework, it's basically what we just did there with the last problem. Alright, have a good day. Oh boy.